Hello, hello, hello to everyone who is just joining us. We're going to get started here pretty soon. This is a pretty exciting live stream today. You all know me. I'm Nick, the AI Developer Advocate for Qualcomm. Hopefully you've seen me on the road somewhere, if not at least online. And I'm really excited today to be joined by Derrick and Rami, who have worked really hard to put together something really, really awesome that I'm excited to share. I'm not going to steal their thunder, so guys, why don't you go ahead and introduce yourself? Maybe Derrick first, so it's alphabetical, and then you can hop into what you're working on, what we're going to
Yeah,
talk
for
about.
sure. Yeah, so I'm Derek. You've seen me a couple of times now. Staff engineer here, with the developer relations group. Yeah, and we're kind of excited about what we have to show today because I think we're doing something very unique,
Yeah.
and something that it's just a different paradigm for MCP. So yeah, I'm
Mm-hmm.
excited to get into it.
Sneak peek.
Nice. Hey, I'm Rami. I've also done a few live streams. I'm a senior engineer at the developer relations team. Mostly do IoT stuff. So this is a kind of cool combination. So
Yeah.
excited for it.
Yeah. We got a compute expert, IoT expert, AI, and yeah. So let's dive in. Why don't one of you guys share kind of what we're going to talk about today, and then we can,
Mhm.
start
Yeah.
with. Yeah, we'll start.
All right. Well, we do things in GitHub repos generally. So I'm
Yep.
going to share this GitHub repo, which will be public soon. But the kind of the overall project that we're doing is a yoga instructor, MCP, and this is both compute and IoT. So it's kind of cool. The client is sitting on the Snapdragon X Elite laptop, which Derek will demonstrate in a little bit, and then it talks to an MCP server, which is the Rubik Pi. But we wanted to highlight like kind of the entire Qualcomm stack and also some of the capabilities you can do for privacy and why Edge is so important.
Mm-hmm.
So for low security questions, we kind of query Claude and do some tool calling, whatever we need. Let's say for medium security, like things that you're comfortable with people knowing, but not like super. You don't want it to be
Yeah.
public information. We're using the Qualcomm Cloud AI 100,
Mm-hmm.
running Llama 3.2 70 billion parameter, and then for high security, we're running the LLM locally on the X Elite laptop with Gemma 1B. And these all funnel back to the MCP client, which does the like handling of the user asking questions and being um, wanting a routine or exercise.
Mm-hmm. Okay.
In this case, it's a camera running. I'll
And Rami, are you
push
sharing?
it over to Derek to. Oh, I just stopped it. Were you not able to see it?
No, we didn't see
Yeah,
it.
I didn't see it on the
Ah, all
Discord.
Derrick,
right.
do you
Let's
have
try
it?
this again.
Okay, yeah, go for it.
Can you guys see this?
Now it's coming up. Yeah.
Okay, cool.
There we
Just
go.
a low graphic. Again, I kind of talked about this, but essentially the MCP client sits on the Snapdragon X Elite,
Mm-hmm.
talks to the LLM, Snapdragon X Elite, or the Cloud AI 100 with
Mm-hmm.
Llama 3.2, or Claude for like low security stuff that we don't care about. And then the MCP client can talk to the Rubik Pi and talk to an MCP server on the Rubik Pi. So
Mm-hmm.
you can interface with, real world sensor data without using natural language and without using anything like, querying an API of sorts. The Rubik Pi is doing TF flight pose estimation and communicating with the MCP server, all that info. And
Mm-hmm.
as always, we always have like a million different ideas, and MCP is kind of cool that you can throw a server onto everything. So we've
Yep.
talked about maybe using Android or Rubik Pi to do text to speech, speech to text. So that way the like Yogi can just ask questions out loud instead of
Mm-hmm.
having to type them into the client. And maybe like an agent to agent yoga influencer that can like help guide the conversation into like a more yoga specific context than
Yeah,
maybe these three have.
Yeah.
Um,
that's awesome.
Yeah,
So,
and just to kind of, oh, I was gonna say before you click off, Rami, just to kind of double tap on, in case you're not quite sure what MCP is, and it's basically
yeah.
Model Context Protocol, and it is essentially, I like to think of it as it's a standard. It's something that is trying to become, it's a protocol. So the World Wide Web wouldn't have been anything without the protocol that drives everything. So this is something Anthropic is pushing. I think they've been pushing it for about a year. It became kind of hot. So Rami and I was like, let's jump on this and tie in IoT. So essentially what you'll have is you'll have your host, you'll have your client, and then you'll have your server. And what we'll be doing today is just building the server piece of it, because what they don't tell you is that what you don't see a lot of is that really most of the heavy work is with the client, and not so much the host, but it's building that client out. And that's where even after Rami and I, after we committed, we were like, oh crap, this, everybody makes this sound easy, just launch a tool, and it connects with Anthropic's client, but they don't really tell you too much about how to create the client. So if people want that, we'll do another one where we go through how we actually built the client, but it'll be open source on our repos as well. So
that's awesome.
Feel free
Talking
to
about
dive
software engineering, it's always way more complicated than it sounds.
Man,
this
was an emotional roller coaster.
Jump in. So my first question was going to be, what's MCP, which you just covered, but could you actually talk a little bit about one of the things I see people confuse a lot is client versus server. It's a little bit backwards compared to what you normally think, client and server. So can you just explain maybe from a high level, just how the communication happens between the two? If you start with an LLM and then Rubik Pi on the other end, how is it going through? What's the client? What's the server? Just so we have a good overview to start with.
Yeah, definitely. So I think because I come from an electrical engineering background, the client server part, it was kind of confusing, but I didn't have a background in what it traditionally should be. But with respect to MCP, your client is going to be basically what we interact with, whether it's via Whisper, we're talking to it, whether for our case, it'll just be the chat bot. The client will delegate your queries either to the host. The host will be where your LLM resides. So what took a little bit of time to wrap our head around was that, okay, your client and your host can sit on the same device, or your host can sit separate from your client. So we're actually showing both of those workflows where we have our local host, which is going to be our local model that does our high security type of stuff. But then we're also going to be sending queries out to another host that's in the cloud, whether Anthropic or whether the AI inference suite. Now, for the server, that's basically just going to hold our tools. And that's really kind of the easy part, is setting up your tools, your resource, your prompt templates. And that's what is going to sit. It only is going to hold tools. So the flow is going to be, we interact with the client. We say, hey, say you have a MCP server that does weather. You say, hey, I want the weather for today. Then it's going to, it's going to send that to the LLM. The LLM is going to say, okay, I have all of these descriptions, and we'll go through this more as we go through the tool building. They'll say, hey, okay, I have all these tool descriptions. Should I use any of these tools? Okay, I want to use the tool that says get current weather. So then it sends it back to the client. The client will delegate that to the server, which then will do its server thing, pull the weather or whatever. And then if there's no tool available, then it can just speak to you in real world.
Yeah, I think the other really good way to think about it is that the MCP server has your data. So kind of like has whatever is interacting with, and then the MCP client is serving you that data in a way that's human readable and handling it. I think that's why we get it backwards, especially because our use case is IoT. It's kind of weird to think about the server being like an IoT device, but in this case, the IoT device has the data that we're looking for, which like in here is TF flight pose estimation.
Yeah, and just to add another layer, we're actually firing up servers to interact with all of this. So that's where it's kind of like, okay, hold on, client, host, server, but we have to fire a server to talk to the host and the client. So yeah, it's cool. Interesting.
Yeah, well, you guys want to get into it then? Because we're 2 minutes in, so I know there's a lot of stuff, cool things to cover. So let's dive in.
I'll stop sharing and let Derrick lead.
Yeah, let's go. Share this screen.
Your screen's not up yet. I'll let you know when it's up.
Okay, let's go.
There we go. It's coming.
Nice.
There we are.
Oh, are you only seeing you?
You're sharing the internal StreamYard.
Man. Wow.
Come on, Derek.
I do this every time.
It's, are you even using a streaming service if you don't have to like check which screen is being shared or check where your microphone is or check if anyone can hear you?
Okay.
That's
There we go. Entire screen, not window. Okay.
Yeah. Give it a second. Okay, cool. You're in VS Code now.
Okay. So what we're going to do is I'm going to actually skip all of the plumbing. We're going to go directly into, actually, no, I'm not going to skip the plumbing. So I'm always kind of torn between if I go start from a blank notebook and just go through step by step, but this is how we're going to do this. So let me go into my, yeah.
I think Command Plus.
There we go. Yep.
There you go. Yeah, cool.
Okay, so this is going to be our MCP server. Let me go in here and just select the one that we want. This.
So what are we starting with first?
Yeah. Okay. So here we go. So then this is all of the, I'm just going to do all of the plumbing, set that up now. This is going to be my setting up my parent directories, my utilities directory. This is going to be basically where I do all of the inference.
To take a step back, this is the IoT side. So this is the Rubik Pi server, MCP server built. Perfect.
Yep. So this is why we have the Rubik. So this is where all of our, after we get our key points, we're going to get our key points, and then we're going to use those to infer the yoke position that we're in. And then, of course, as Rami mentioned, we will be using TF Lite model. So HRNet pose, TF Lite. And then let's go ahead. Now, in this pose model inference, like I said, I'm going to pass in my model. I'm going to pass in my delegate, which is going to be my our MPU, which you do have access to on our IoT device, which shall not be named. So then from here, we're going to go ahead and set up our fast MCP. And what this MCP is, this is where we're going to basically, if you're familiar with Fast API, it's almost exactly the same, except they just added some few things. Yep. So you're going to have your name. I'm going to call it this IoT device, MCP server, our host. And then this is the port that we're going to use to access this, our server, which is going to be, and we'll SSH into this. I am using a real device. So the first thing that I'm going to set up, and this is just setup. We're not even getting into the tool calls or anything yet. This is just going to be, I basically created like a routine manager. And what this is going to do is when I query when I go into my client, I say, hey, I need a yoga routine that helps me with so-and-so, so-and-so. It's going to build that routine, and then it's going to store it in here. And then I can use this manager to go to the next pose. I can use this manager to understand how much time is left in the sequence and do all of these interesting things. So this is what I'll be using throughout. Okay, so now let's get into our first tool call. And this is going to be after we do the prompt and say, hey, I'd like a yoga routine that helps me with lower back pain. It's going to create this routine. And then I'll say, hey, after it creates the routine, I'm going to say, okay, now, and remember, this is the client that I'm interacting with. I'm going to say, hey, now I want you, let's begin this routine. And when I say begin the routine, it's going to send it to our host, which is our LLM. And then the LLM is going to, what the LLM reads is it's going to get a list of all the tools with this description. So this is very important. This is where I felt like I was starting to get into, dare I say it, prompt engineering with this thing, because it was a lot of iteration to get these descriptions right to make the tool calling more accurate. And then it got even more, which we'll talk about that later. But basically, so when I say let's begin this routine, the LLM is going to, the host is going to say, okay, I think this tool, I should use this tool. So it's going to say, okay, begin routine. And I have a cached routine after I get it from the LLM. And it's going to start this. It's going to feed this information. So we do our tool, we have our description, our doc string or our description from the host perspective. And I also use this, and I don't know if this is standard, but I didn't want to handle different system prompts per tool. So I actually have I use this doc string as a system prompt as well. And you'll see that as we go into some of the other tools. So our first tool is pretty self-explanatory. It's going to get complete routine. It's going to start at the first index, which is going to be the first pose. This is just going to say, is there a routine active? And it's going to get our start time.
Okay.
First pose, complete routine. And then we're going to send this as a string back to this goes back to the client, which ultimately gets delegated back to our host. And then from the host, we'll read this and be like, oh, okay, there was a tool call. Here's the results from the tool. And then it's going to take that information and give it back to us in real language.
Okay.
So now our next tool.
So before we get too started, just to clarify a couple of things. In this case, when you say host, you mean LLM.
Yeah.
But like we talked about, there's 3 levels of LLM, right? So there's kind of that delegation, and that delegation generally happens on the client side, right?
Yep.
Sweet. Cool.
Yep. And that, so from the server's perspective or our IoT device's perspective, he doesn't care where this information is going to. He just knows that he had a tool call and I'm sending it back to the client. The client says, oh, okay, this query said it was personal. So that means I need to go to high security. Or this query said, oh man, he has some kind of pain. Let me keep this private, confidential, and run this on device. But from the server's perspective, he doesn't care.
Yeah.
Okay. So now for our next tool, I'm going to say get current pose. And I want to know, and this is where the inference is going to come in that's being done on our IoT device. I want to know, once we start a routine and once we're in the initial pose, am I actually in the correct pose? So for the doc string, I have get information about the currently active pose, important instructions for the LLM. So this is where I'm using it as a system prompt as well. I'm using the doc string as a system prompt because the LLM is going to consume this. So I don't have to manage a different system prompt for every single tool that comes in. Just throw it in the doc string. So important instructions, detected pose field is the ground truth. So what I get from the sensor, that is true. And I had to add this because sometimes the sensor would be like, oh, the LLM would be like, oh, you're supposed to be in this, but the sensor must be wrong because it's saying you're actually in this. No, the sensor is always right. No question the sensor. So add that. If detected pose matches target, give positive encouragement. All of this stuff is LLM stuff. Example, I see her in child's pose. Let's transition to cat cow by, you give these examples. Okay. If prompt is for time left, do not speak about current. And this is still kind of iffy. I'm still trying to get this right because if I say, hey, how much time do I have left in this pose? It shouldn't matter because I should still be in the pose. But for this, because I don't have whisper enabled yet, I have to type. So it'll actually do the inference again and be like, oh, I see you left this pose. Let's get back into here. And you have this many seconds left. So this one still takes some iteration. And then again, never question my sensor. The sensor is always correct.
I have a question for you, Derrick. I think hopefully everyone in the audience, if you haven't heard of MCP, you know that at least using AI models, the prompt can have very drastic outcomes because it's probabilistic. So if you even change one word, you could potentially really divert your answer. Were you surprised by the process of actually coming up with these prompts? And once you're surprised, was it harder than you expected, easier? What stood out to you as you were doing that?
Yeah, no, it definitely, it was definitely a task. And it's like, the more you prompt, the more you start understanding patterns. So once you understand the patterns of what the LLM kind of trends to, then you know what you need to add into this doc string. But then, so when we're returning the when we're returning the JSON for the routine, which you'll see, that took a lot of prompt engineering, because I needed that to be deterministic, because this is going to parse that JSON a specific way. So I needed to stay in that format every single time. And Claude, our low security host, he gets it right every time, which makes sense. Our local host, it took some effort. So when I see that I'm asking for a routine, I have to override the temperature. I have to reset the temperature. I have to reset the top K to make it as deterministic as possible. And sometimes it still gets it wrong. I have about a 95% hit rate with
that's pretty good.
Yeah, we're creating the correct JSON. Now, hopefully I don't put my foot in my mouth when we actually go through the demo.
If it happens, it happens. And one other question, actually, how much time did you spend actually working on the prompt engineering versus if we look at this tool, right? There's code, and you knew what you wanted to do with the code. What was the ratio of time spent on the doc string to get your prompt right versus actually writing the code? Because I always like to call that out.
That's a good question, because we had to get this up and running. We had to actually do a lot of novel stuff. So we spent a ton of time on the code. But in creating the code, we're also, working on the prompting. So it does something you don't want it to do. So I don't want to say it was equal. Definitely more time was spent in trying to understand how to put this together in the code, because it was so new at the time when we first started this. Even the freaking LLM couldn't help you. So you would ask the LLM a question, it'd be like, "Oh, it's hallucinating." Now you're off in the weeds somewhere, and it was really a simpler solution. So I would say, the actual coding part took a little bit more time. But once I completed the architecture and all of that, then it's just iterating, asking questions, seeing what comes back, iterating. You start recognizing patterns, adjusting the prompt, adjusting the temperatures, and basically what I'll call hyperparameter tuning, prompt engineering, temperatures, everything. So this tool will just get our current pose. Same thing that we're doing. We're going to do our inference. If the routine is not active, that just means that, hey, I just want to know what pose I'm in right now. We're not a part of a routine. And we're going to update some stuff. And you can go through this for the lack of time, because I kind of want to get to the demo also. And then after that, we're going to return a JSON. This is what will get sent back to the client. And then the client will delegate this to whoever he needs to. Okay, so now we have another tool. And I'm going to start going through these pretty fast. So now our next tool is going to say next pose. So we began our routine. We have a tool that will give what our current pose is. And with this current pose tool, we can also say, hey, how much time do we have left? What's the current pose number? All of these different things. And the LLM, and the beauty is we're passing a JSON back to the LLM, but the LLM is going to read this and give it to us in real language. And this could be just a string, and we could pass it back. So I think that's really the benefit of the LLM, is just taking these different types of data and feeding it back to us, like how if I'm talking to you or I'm talking to Rami. So next pose is pretty self-explanatory. We're going to iterate the pose index, and we're going to go to the next pose. Next pose format, same thing again. We're passing we're passing a dictionary back, but ultimately it's dictionary JSON, potato, kind of different, kind of the same. And then for this one, so now this is when I started really kind of becoming a believer in MCP, because I realized that with certain poses, I really don't even need the separate yoga pose model that I trained, because I can say, like it would say, so this is going to give you the raw key points. So with this inference, when I'm getting the pose for this guy, and I say pose predict true, it's actually going to take those key points and then run it through another model that I trained to make a prediction on those key points. But I had a case and I just tested it out where I was like, hey, based on the raw key points, am I in the correct pose? And it was like, oh, based on what I'm getting from the key points, it looks like you are in the correct pose. And this is why, because we're using, everybody uses this, you have these 17 body parts for this pose detection. It's pretty standard. So it was able to get that. And then just to make sure it wasn't hallucinating, I got in another pose and that was totally off. And it was like, based on the key points, looks like you're not. Let's get back in position. So this one, this started making me a believer of this and, and where this thing can go, because the implications of this is I really don't even need another model. I didn't need to train another model. Just feed the LLM the raw key points and say, figure it out. Okay, so now our other tool. So with this model, and I wanted to retrain it, but I got caught up in trying to make tool calling work locally, which it does, which I'm kind of proud of, which I'm going to show. But yeah, so this is just list detectable yoga poses. And basically this is going to go into our pose and it's going to call this pose predictions. We're going to pass that back and the LLM is going to say, hey, these are the poses that I'm able to predict. So if you give me something outside of that, you're on your own. Good luck with the raw key points. And then for our last tool, we just want some basic data. And this actually could probably maybe be a resource. Some of these can be resource, maybe. I just made everything a tool call, but technically on the server side, you have tools, you have resources, which is basically just getting information, getting data, getting docs, whatever. Then you have prompt templates, which I'm not even 100% sure what that is. But those are the three kind of things that you have. For this, if I want to know what IoT device that I'm using, I can say, hey, what device is this? And it'll return this software info. And I could have probably made this a little bit more robust and pulled it directly from the device, but this is how we're doing this. This is kind of low-hanging fruit. Oh, no, don't want to save. And then that's it. So we have what? 1, 2, 3, 4, 5 tool calls, and the sky is really the limit. Like, I really wanted to add Whisper on this, and that'll probably just be something that I add on the end on my own time.
Or
because that would have, that would be even better. That would be even better, because that would be cool to just be able to talk to and say, hey, I need a yoga routine to do X, and then, hey, okay, am I in the right, and just talk to it in real time. But there was so much stuff that I didn't know needed to be done to make this work. Anyway, so this is, like I said, we have to start this server. We're doing the transit. If you have standard input output, this is going to be a streamable HTTP. And this will allow us to SSH into the device. So now I think I just want to go into the demo.
Yeah. And
then we can kind of talk about some of the now, because, Qualcomm, we're all about the edge. And there is some novel stuff with the OpenAI adapter. And if you want to know, if you want more details, let me just put that in there. If you want more details about pose detection was the very first Discord live session we ever did back in January. There's a video on it. There's also, we have the blog that shows you exactly how this is done. And then for the LLM, our local host, if you can refer to the DeepSeek one that we did back in June, that has the blog, and it's essentially, it's the same exact thing with how to do the LLM inference. I'm just adding an OpenAI wrapper, OpenAI API wrapper on top of that.
And the reason we did that, for context, the reason we used the OpenAI API is because we wanted one way to be able to talk to all three of our LLMs, right? So it's important to note, like, we could have done custom tool calling for every single one of those servers, but then we would have had to like post-process that information in the client and make it look pretty and make it work across all three, which would have been just, blown up our lines of code. So it was a lot easier to use OpenAI API because that's supported by like the AI 100 chipsets that we have. It's supported by Claude. All we really needed to is support the LLM that is local, which I think, Derek, you're about to cover next, correct?
Yeah. Yep. And since we're just, this is very ad hoc, I'm smiling because I remember when I had the inference running on Onyx via Onyx runtime, and and everything was going smooth, and then Rami's like, oh, look, the Sierra Scale, which is our host for our cloud servers, they use the OpenAI API. Oh, Anthropic uses the OpenAI API, and Rami's like, we should really use the OpenAI API for the Onyx runtime. And I think, I was like, I was trying to fight it in my mind, and I just probably didn't respond anymore because I was like, I just put all this work in, and I slept on it, and I was like, okay, it does make sense, so that we just use the same kind of template.
Yeah.
And then we were off to the races creating this wrapper, which ended up being a lot more involved. But so that was just kind of funny because at first I was kind of reluctant internally, and then I slept on it and was like, okay, Rami, this does make sense. We need to create this wrapper. So I was probably cussing him out a little bit at night too.
Oh, that's okay.
I just put all of this in. He's talking about we need to create another. Yeah. So fun side piece. Anyway, okay, let's get into the fun part. So this is the code already done. As you can see, I'm SSH'd into the device. So this is actually our IoT device, and that's the beauty of doing this via VS Code is they already forward the ports locally, so I don't have to go into a terminal, SSH into the device, and then create another SSH tunnel to my device. So that's nice. But what we're gonna do is we are going to fire up this server. So where am I at? cd git yoga instructor. Yep, Python Rubik imain.py. Oh, but before we do that, I'm gonna fire up this server. Another very cool thing. So right now we're just so now our server is fired up. Starting in SSE mode, we're using X-Impact on the CPU for specific reasons. But now that we have this server fired up, I do want to show something that actually came about. Oh, okay. I thought I was froze up. As we were developing this, and this was kind of like fresh, hot off the press, or maybe I just didn't know about it previously, but we can actually inspect. So how do I want to do this? Let's go here. So they have this MCP inspector, and now that we're port forwarded to our local machine, I can call this as is. So when we do this, and this is what I use to create the tools and to make sure that the tools were doing what they were supposed to do. So it's going to open up. Huh?
Is this from FastMCP?
This tool? This is
I
from
think
MCP.
Yeah.
It's cool. From Anthropic. Yeah.
Okay. So what this fires up is we have this. And now from here, I can connect to, because you can't just, do curl commands and connect to this server because you lose state and there's some stuff that happens that we don't see that's going on. But if I connect to this,
or not.
Oh man. Yes. Okay. Now let me connect, please.
I guess it's a refresh. Yeah.
One option I see is Fresh Air Barbecue.
Whoa.
Here's some music from your.
Why are you not doing this? Okay, let's try this again. Actually, let me try this. I mean, that shouldn't make a difference, but okay. I really want to show this, so please just connect.
Otherwise, it'll be self-exploration later.
Yeah, but this is really nice.
Sounds like it's time to submit a ticket to Anthropic's GitHub on.
Man, why are you doing this?
So what does that do? Since it's not working, can you just talk us through it? In 30 seconds.
So basically, you put your host into here, and then you can actually see all of your tools, and you can interact with your tools and ensure that they're doing what they're supposed to be doing.
Cool.
So let me hold up. No, because I really want this, because this is really cool. So let me just shut this down again. Let's fire this up again.
One last chance.
Yeah. Okay. So now exit this out. You work. Why? No, this doesn't make no. Streamable HTTP. Man, that is crazy.
It's
Anyway,
It's all good. Let's,
okay,
we can
yeah.
just
we'll
talk.
talk
All right.
Client
later.
side.
Yeah, let's
Anyway.
get to the demo.
Okay, so now the next thing I have to do is I need to fire up my, not here. I need to fire up the Python source, open
I think
API,
you're trying to say the
OpenAI.
LLM for.
Yeah, the adapter. My fault.
Yep.
Okay.
So once I fire up this adapter, now this is gonna be the server that allows me to interact with. That's right. MCP x86 scripts. And then now let's do this. Now we should be good. Okay, so now this is going to fire up the server that allows me to interact with the LLM that I'm running using Onyx Runtime, but with an OpenAI type of interface. So
And
when
this is
this
still the one
fires
on
up,
the IoT kit, right?
huh?
No,
Yeah,
this
this
is
is
running on X Elite.
No,
Yeah,
I
this
know
is-
that, but it's interacting with the one that's on the IoT kit, right?
No, this is still, so this is an adapter. It talks between the client. Well, the client is going to call it. It's going to launch a server
Yeah.
in the
okay.
background. The client can call this, and then this will translate whatever OpenAI's format is to a command that runs on Onyx so that we can do the inference
Gotcha.
locally.
Okay. Okay.
So
cool.
this is kind of like what Scale does in the background, or even Anthropic or Cloud. They take the inputs from OpenAI in a standard format, they
Mhm.
deconstruct them so that their LLM can understand it and then respond with whatever is needed.
Okay. Cool. That makes sense.
What could I be running into some server host conflicting thing with the StreamYard? Why the heck?
It's possible. Or check your other terminal windows. Maybe you have a server running somewhere that's.
No, because I shut this down. So this is a complete new.
So what's missing here? What are you expecting to see?
The server startup.
Oh.
Can we launch the client and do a quick demo without the local bit?
Yeah.
And then
Let's
we
do
can
that.
come
That's
back and
probably
debug that.
a good idea.
Yeah.
Do you
Yeah.
have that, Rami, or is that still on Derrick's machine?
Yeah, I have it.
Okay.
Yeah. Okay. So let's go ahead and just do the.
So we also have some commands. So if in case you need to like force it into low, medium, or high, you can do a / command and force the providers to what you need them to be.
hmm
This thing is not connecting to anything.
Yeah. Are you sure you don't have another terminal open? Because that's what I would guess, just based on maybe in VS
Yeah,
Code,
no.
in one of the VS Code windows.
The only one that's fired up is this Ruby Pi guy.
Yeah, that's weird.
Man, is it a? Okay.
Rami, do you have the
Okay, let
code?
me
by
just.
any chance?
Yeah, let me see.
You want to give it a shot? Okay, one more time. Whew. Oh, the virtual environment's not activated.
Yeah, no, that's how I'm supposed to activate it. What's going on with this thing? Okay, this is doing something weird. Okay, I'm going to restart really quick. I will be right back.
Okay. Rami,
When
then
all else fails, I'll
your
be right
shot.
back.
Yeah, I'm working on moving. Unfortunately, my dev computer and this computer are different, so it'll be
I get
interesting
that.
to transition that. But
Yeah.
yes, lessons learned for last time. Have 2 backups, maybe 3.
That's a good life lesson for any live demo when you're doing it.
Yeah, right.
Yeah, I just saw Timbo. I see your comment. There's something like that happening. There's some sort of socket or some server that's open, so a restart will probably help. I was gonna say close all the VS Code, but if he restarts his computer, it should be good. Yeah. That Derek's rebooting. We've seen that a bunch of times. So, Rami, is this your first time working with MCP while we wait for Derek to come back?
Yeah, this is especially MCP IoT. When we first started, I had a couple of MCP servers that I wanted to play with. Like the GitHub one is, I think, the most popular
Yeah.
and super fun.
Mhm.
So we got that up and running. But you know, you see all the crazy stories, especially with like token usage and how expensive MCP can get. We're like, oh, it'd be really cool to be able to push that into something that we could
Yeah.
use on a local device. And then with the IoT, like I think IoT is pretty inhibitive in general to the normal average user because they can't
No, I agree.
interface with
Yeah.
it.
Yeah.
So having something where you could use natural language to interface with it has been a game changer for
Yeah.
us. It's been fun.
Do you think is it into your workflow now? Are you sold on it, or do you still have some things you want to explore before you make a judgment?
I think just like everything new technology gets a little bit overhyped to begin with. So I think a lot of people are using MCP servers where they don't belong necessarily. So we're very interested in like figuring out where the right combination of
Yeah.
MCP server, MCP client, or just a classic REST API makes more sense.
Yeah. I I don't know. See, and I've been thinking about that too. I'm glad you brought that up because you see just because of all the hype with all of these technologies, even since Gen AI came out in the past 3 years, there's people who are over engineering problems. And the same thing happened
Mhm.
before, like big data, same thing. It's like, oh, I need to have a giant data lake and I need all my data to be streaming through my sockets right in real time and blah. And it's like not every case needs to be so over engineered. And so,
Oh, 100%.
and not everyone likes to admit that because it is cool to have all these technologies and work with them. But we still use C and C++ because they're good languages that have stood the test of time, and a lot of the paradigms that people have used to code have also stood the test of time. So I'm glad
It's
you called that
interesting
out.
too. Yeah,
Yeah,
it's interesting too, especially with IoT. I'm curious to see how things shape. Giving
mhm,
control to an LLM is a little bit scary. I feel like that's
yeah.
reaching like Terminator levels now of the
It's starting
LLMs
to
control.
engage with the physical world. Yeah.
Yeah, exactly. Which
I
is
mean, they're
always
putting them
funny.
in robots, though. To be fair, so I mean,
It's true.
there's a company I've been like somewhat following on LinkedIn, like Figure, and they make
Mhm.
humanoid robots, and they have their own AI that they put in the robots, and they're teaching them to do stuff, and they're not very advanced, but you
Yeah,
conceivably over time, as they get exposed to more scenarios, and the reinforcement learning, iterates over months, years, they'll get better.
yeah. I mean,
So,
yeah, it's interesting too with MCP specifically. I think I've read quite a few stories of people that are like, "Oh, whoops, you know, it just I used MCP GitHub and all of a sudden my production is down and like it's
yeah,
unrecoverable now because it did some wonky commands to try and get it to work."
yeah,
Can't imagine doing that with IoT devices, but it's also super fun to be
yeah,
able to do things like that.
yeah.
Just
I mean, that you start to get in gray areas once the hardware itself is capable of behaviors you don't
yeah.
want. You know, when it's like when it's a little board, you know,
Yeah.
sitting on your desk, it's fine because it's just there and it can't move. But you know, give it wheels, give it arms, give it, you know, a way to engage with the world, and then you're starting to really get potentially into trouble if you're not careful.
Yeah, I've been thinking about a moving MCP demo with IoT for
Uh-huh.
quite a bit. I was thinking like 3-card Monty type thing, but we'll
Yeah.
see. We'll see what we come up with next.
Yeah, that's you know, and it's not unusual. I mean, there's different things. You know, MCP is similar. Like you get better workflows with your AI calls. You can really target it, but also you're still going to run into some of the same issues. Like I just saw a couple weeks ago, there was a team that like dumped their entire production database, like you're saying, or even if you look back a year, there's people who were using AI to code, but they didn't, you know, create new branches and all that. And so it would like overwrite the entire repository and it's
Every single
unrecoverable.
time. Yeah.
Yeah. Yeah. So it's like, it's new workflows you have to get used to. And I think, you know, IoT is like definitely a new frontier because now you're really pushing up against the physical world. So it's going to take time for that to settle down.
Oh, we
Okay.
got Derek back.
I'm back. Yeah, no, Streamlit was hogging one of my ports or something. So
Well,
I fired up all of my servers before I got back on.
nice.
So, okay,
Next
now
level thinking there.
back to the MCP. Oh, did it cancel my? Oh, you dirty.
Dirty dog, you.
Oh, it was just up. Okay.
Well, it looks like it's still there in your terminals, but it's not working.
Yeah, okay. Anyway, let's talk to it. Let's see if okay. So we have this is going to be our Rubik Pi server right here. We're going to start with low security, and I do have the client, this server up to. So this is going to be the local, the OpenAI adapter that's up. Hopefully it's still up. So what we're going to do now is, and we're going to just stay low security for now. So low security is going to interact with Claude. So, hey, I need a yoga routine, to help with tight shoulders.
Never underestimate live typing. It's so much harder than it looks.
Man, and it doesn't help that my adrenaline is like freaking going now because the thing wasn't working. Okay, so you see Claude was quick. This is the JSON format that it gave back. This is what I'll use to parse. And just to be 100% sure what's going on, I can go and I can see client. And we see that it's called shoulder opener. And like I said, Claude gets this right 100% of the time. So here's where I cache the routine. We see a shoulder opener. It cached this routine. Now, when I do my first tool call, which we're going to do now, we're going to see this is the Rubik Pi right here. So now let's say, okay, let's begin this routine. Now Claude is going to say, okay, I think I need a tool call, begin routine. That's the one that we use. And we see that the first routine is cow face pose, face pose. But because that JSON was sent back to the LLM, it says, great, let's begin the shoulder opener routine. We'll start with cow face pose, sit up tall, reach your arm up and your left arm. This isn't one. So actually, let me do another tool call really quick. Let's say, hey, what tools, what yoga poses are you able to predict? It's going to say, so it's going back to, list detectable yoga poses. These are the ones that it's able to predict somewhat. Okay, so now I'm going to ask it, that we began this routine. It's telling me to get into cow face pose, whatever that is. I'm going to say, hey. Okay, no, I'm not going to say hey.
A challenging pose, too. It's kind of funny that it's suggested to start with.
Man, I have no clue. Am I in the correct pose? Now, if you look down here, you'll see what's actually predicted because I have print statements on the server so I can see what's going on. So am I in the correct pose? And I'm just going to I'm going to back up. I think my camera is still pointing at me. And it's going to say, this is not tree pose, but maybe I'm not far enough. I don't know where my camera is showing. It says, okay, it looks like what I'm predicting, my model, look, we're not focused on the accuracy of my little yoga model. I can make it better. But the model predicted tree pose. It sent it back over. The LLM, the host is saying, It looks like you're currently in tree pose, but the target pose for this step is cow face. Let's transition into cow face. And then it kind of tells me how to transition. Let's say, hey, how much, let me stop saying, hey, how much time do I have left in this pose? It's going to do another tool call where that time is at. It's going to do another prediction. There we go, mountain. There we go. That's what I wanted to see. Great. It looks like the 60-second hold for cow face pose has been completed. Nicely done. Go ahead and switch. Okay, let's go to the next pose. Let's move on to the next pose. Calling next pose, a tool call. Okay, so great job holding that cow face pose. I didn't, but now we're doing thread the needle. Not sure what this is either, but I'm going to do another pose. Okay, so great. Am I in the correct pose now? And I'm gonna, hopefully it gives me this warrior guy. Let me see if I can get into it quick. Oh, look it gave it to me. Oh, it didn't. Okay. Anyway, it got it one time. So wonderful. It looks like you're in the, are you sure? See, we're hallucinating now. Are you sure I'm in the correct pose? Oh, wow, it's 9:52. Okay, I need to go to the local part.
We can go a little bit over if we have to. I mean, we don't.
Okay, so now it's going to do a tool, and it didn't call. Oh, it got the key points. It did the tool. Based on the so this time it called the key point tool to get the raw key points. It says, based on the detailed joint data, it looks like you may actually be in a child's pose rather than, which we're not. So, this is my model. So now, so that's how we interact with, and then I can say, hey, what device am I using? It's going to do another tool call, Rubik Pi. Oh man, IoT device software information based on the system information. It looks like you're on an IoT device. This is a specialized computer vision. It adds its own stuff to it. Okay, so now let's go ahead and clear this, because now we're local and we're going to move local, and we have a context window, which makes things a little bit more interesting. So as Rami said, we can do this clear, and it's going to clear all of the conversation history. So now I can say, hey, this is personal. Personal, Jesus Christ. I need a yoga routine that helps with my lower back. Now we're going to get into some probabilistic stuff that, we'll see how this goes. And this is for my local guy. So we see it's changing the temperature. And just to prove that we're running locally here. Okay. Oh, good. So it's going to give me my JSON format. And because I have all of these windows open, it's slow. And actually, how I had to implement tool calling for local, because most models, bigger models, they'll have, it's trained for tool calling. This 1B model isn't. I tried to put in a tool. It doesn't do the tool calling. So we had to actually do something rather unique and novel. Maybe I'll write a paper about it. I don't know. To basically make the tool calling more deterministic. So now how I'm doing tool calling locally is not based on the LLM deciding what tool. I'm not feeding all those descriptions to the LLM. I'm doing something different. So this is taking forever because I have a million things open. Let's just make sure. But you can see that I promise you this usually runs faster. But it's only using 22. Usually we're at like 59, 60%. So something else is hogging the CPU. But it looks like this is giving me it in the correct, oh my God. And it doesn't help that I have to, so I had to go into an emulated version of, which means that we're not on ARM64, we're going through an emulated layer. Because I needed this in order to do my custom tool calling method. I needed an embedding model, and I tried to use Gemma's embedding, it wasn't that good. So I ended up getting this sentence transformer, and that's what it, but I didn't feel like building it from source. It only is available on x86. So I had to use the emulated version. So that's probably slowing us down somewhat too. And we're
It's a
slowly
natural
getting there.
consequence too of being at the edge. You know,
Yeah.
a lot of, you know, you if you go in expecting the edge to work just like the cloud, it's not going to. And that's partially a function of lower resources, you know, smaller models, but it's also a function of early on in the like edge journey. Is we started from the cloud, from the big data era, so we threw all our models up there, and we're only starting to get into a place now with hardware where you can run these models really performantly and efficiently at the edge. So over time, it will continue to improve more and more.
Good. It only gave me 3. Sometimes this thing will give me like 10, 20. And I promise this is significantly faster. We're probably getting at least 10 tokens per second without everything else hogging up the CPU. But yeah, so we finished. We got the JSON format. I didn't get an error saying it was the wrong JSON format. So let me just be 100% sure that it actually, it did what it was supposed to do. Let's see. It did update. Yeah, no. So it must have been the wrong JSON format. But yeah, this is what we have to deal with. Anyway, so now let's stay high. This is personal, but let's begin this routine. And I'm saying this is personal so that it stays local.
Yeah, it triggers it.
So now it's doing my little custom tool calling thing. It said, okay, call begin routine. And I'm reminding you, this model, I didn't fine tune this model on, and it's going to CalFace pose again. I didn't fine tune this model on tool calling. I basically created my custom way of calling tools that gives me a pretty accurate rate. It didn't really give me much back. That sucks. Sometimes it talks too much. Sometimes it talks too little. So it says begin routine, started shoulder opener, now on pose 1, cow face. And that's just because this wasn't in the correct format. So basically it rejected this JSON format. So, okay, so now same thing. Yeah. So let's move to the next routine. Oh, personal. So that it stays high. We see it's doing my little, oh, okay. So it didn't really call that. And let's see why. So it said 43% begin routine. Get next routine was 30.36. So it said begin routine. Yeah. But that can be fine too. I literally got this together in the wee hours of yesterday night.
And again, it's normal. I mean, we can't emphasize that, you know, really when you're working with these sorts of technologies that are so new and you're at the edge, it is going to take some time and some effort and fine tuning to get these to work specifically the way you want. It's not as simple as, you know, using Claude or OpenAI, which have, you know, huge amounts of parameters. So, I mean, we're working with 1 billion parameters that are quantized down. So they're running at the edge, you know, relatively quickly. And you lose a lot of context just by changing the weights of the accuracy of the weights. So the fact that it's working decently well is, you know, this is a huge achievement.
Yeah, and just to remind you, this model isn't fine-tuned for tool calling. The tool calling is being done is I can get it more deterministic. This was just the first pass at this method that I wanted to use. But now you can see when we do call begin, it actually gives me a response. Okay, let's start with start shoulder open pose. I'm going to gently shift your shoulders to the left, initiating a shoulder rotate. There you go. Let me make this a little bit more deterministic. Personal.
I want to add too, this is like the big bulk of this project is writing the pipelines between both Edge, IoT, the host, and having a client on the X Elite. The fine tuning, we'll leave that up to you your hands. Because it's kind of cool. We can do whatever we need.
So for our scores, next pose, it got 55. So that was the highest. It said, okay, let's use that. And it's going to return. So, you know, and this is what, as Qualcomm, what we should be doing is, because we're focused on local on the edge, is finding ways, because a lot of people are fighting for, oh, what model is, you look at Reddit, what model is best for tool calling? Of course, Anthropic has it down. OpenAI has it down because they have these
Llama's pretty
huge,
good too.
yeah. But when you get to the edge, you need small models. So you need to think of more innovative ways of doing some of the stuff, because you can't jam everything into the model. So anyway, that's running. And if I had the time, I would have added streaming to this so you could see it come here. But we can see on that local server that it's very slowly running. And I promise, I keep emphasizing, if you go to the DeepSeek video, this runs way faster than this. It's just, not only is it not on NPU, it's CPU. Yeah, but it's also, there's a lot of stuff hogging the CPU right now.
And quick shout out, hang on one second. Quick shout out about agents, by the way, since we were talking about tool calling. I dropped a link in the chat that is for a local agent repository that, I've taken to a couple events. I did it at Microsoft Build. So if you want to see like the real basics of how do you start with an agent from scratch and just understand tool calling, that repo has just basic code in Python. And then there's a resources section that includes a write-up by OpenAI about how to build agents. So you can go and look at the code, build your own, and it's extensible. So feel free to explore that as well to get a better grasp on tool calling.
And then whenever this thing finishes, we'll just do another quick prompt. It's almost done. It looks like it's almost done. It's giving me an overall assessment.
We got
and then we'll see. We'll watch. Yeah.
We got a question saying, could these things be run on the 6490 chipset like the Rubik Pi locally offline? So the tool calling is all running on the X Elite offline. The Rubik Pi 6490 is running the MCP server. So that's what's interacting with our sensors, in this case the camera, and doing the inference and then returning whether the user is at the pose that they're currently at. So we're kind of using that like tiered system where we match what level of inference we want to do based on the SBC.
Okay.
Yeah, but to answer the question, the way I'm implementing tool calling, it can very much be ran because we're not hitting an LLM to determine what tool needs to be called. Let's go to the next pose. And then it's going to go back to low. We don't have any personal. It's not confidential. It goes back to Anthropic, and we see it's freaking, I completed everything. So
good job.
So that's that. But with the tool calling, what I want to emphasize is that you don't need a model that's specifically fine-tuned for tool calling to get pretty accurate results, as I just showed. So if we just go really quickly into what's going on with and this is all going to be, this is all on the repo already. But for the tool calling, so this is the OpenAI adapter that needed to be created. So this is, and if you want to be able to create an OpenAI adapter, this will get you there. So now it interacts with the same kind of API calls. But for tool calling, for the tool calling, basically what we're doing is I'm vectorizing both the description and the query, and then running it through this sentence transformer, taking the dot product, getting the similarity, and seeing and basically determining what the similarity is. If the threshold is below a certain point, then I know it's just going to be a request. It just goes to the LLM as is. If it's above a certain threshold, then it's going to take the max of those different tool calls, and it's going to inject that into the proper tool call format, and send that back to the client, which ultimately goes back to the server, which the server will run the tool, send it back to the client, and back to the local LLM to post-process it. But like I said, I guess I don't really need to go through all of this. This will be on the repo. And if you just want an OpenAI adapter, OpenAI API adapter for whatever you're doing, because in the back end, it's all just running. I was going to implement DeepSeek. I didn't. DeepSeek talks too much. It's just implementing this.
Gemma.
And this is and this is already in that repo as well. And this is
So
all
we have another
Onyx runtime.
question.
Yeah.
We have another question actually. So, and I think the answer is yes, but I'll let you guys answer. Can we run small LLMs like 1 billion or 3 billion and integrate it with MCP on the Rubik Pi NPU or HTP? So they're talking about the QCS 6490. So that's a 1 billion parameter, right? Does the 3 billion fit?
1 and 3 billion fit. Even like you can even run them on the CPU on the 6490. NPU HTTP support. If you technically Genie isn't officially supported, but you can still run them on the HTTP on the 6490.
Yeah. How does it affect performance? I mean, do you like, is it worth it, or do you think that, just running it as is good enough?
It's worth the performance if you're looking for performance only. If you're looking for performance and accuracy, which I would argue most people are, the amount of effort in is pretty large.
Okay.
But to be clear, if you're running the LLM on the IoT device with the tools, then you don't need MCP. MCP is essentially a way to kind of abstract where you're calling your tools from, so like it wouldn't make sense to have our LLM as well as our client as well as the tools on the Rubik Pi. It's a way to have where now on the 6490, we can have a set of tool calls for that, and then you can have a set of tool calls for the IQ9. You can have a set of tool calls for all these different IoT devices, and they all interact the same way with the client that we built. And if you need an LLM, then you can either go to Anthropic, as we shown. You can go to Cirrus Scale, or you can go to local. And the reason, so we do have. So if I say my company now, the reason I didn't really hammer on the cloud on the Cirrus Scale, our AI inference suite, is because there's something going on in their API. So if I want to say, hey, my company wants me to have a yoga routine to help with calves. You see it goes to AI 100, and it's not our tool, it's their API. Something funny is going, it's using a tool, and this is an API issue because as you see, it worked with Anthropic, it worked with local. But if you are interested in, so I can plug this in, if you are interested in going to our inference cloud, you can do that, and you can actually get started, and it works very well. So if I just put in this prompt, and this is what I did to make sure that I knew that it worked. Where is my MCP client? Let me just say, I'm not even gonna do, but let's go. You can go all the way up to Llama 370B. I need a yoga routine to help with lower back. There you go. This is running the 70B version on our cloud inference server. Now, they have some work to the API, which is why we can't really, I can't showcase it the way I want to in this scheme, but you can see that with this client, once they fix the API, then this will work for all levels. So if you have some company level, and we're using Yoga because that's what we use for pose detection and Onyx runtime, because we want to tie in all of these build alongs, but this can be abstracted to anything. What we really are showing is that MCP interacting with IoT, and
So another question that just came through is Gemma 3N and QCS 6490 supported for QNN? So those are two separate questions. Rami dropped it in. It's not officially supported, but you can use Onyx. If you can convert the models to Onyx and you get it converted successfully, which is a feat in and of itself. So I'm making it sound easier than it is, then it will be supported because the Onyx format is supported. But we don't have direct, fully optimized support in our format yet.
Yeah. And so there's also some more work, I want to shout out the Tiny MCP guys. I'm looking forward to starting to contribute to that because, this stuff will be on the edge, and there's a lot of things that have to be figured out to make this robust. Tool calling was just one small piece.
Yeah. What would it be like? Can you talk us through that as we start to wrap up here? Like what I know you've mentioned Whisper, for example, like that's something you could add so that you can actually directly engage with it by voice. But what else would take this to what you would call a complete prototype? I don't think production level, because that's a little too far, but what's missing?
Mhm. Yeah, so from my perspective, I mean, we have tool calling that can be tightened up. Really, I would just want to add Whisper to this. And then also, take some time, take a step back to go back and optimize the Gemma 3 1B graph so that we can run that fully on NPU. Then we wouldn't have kind of these lagging issues. But other than, I think, adding Whisper so you can just talk to this thing, tightening up the yoga detection model, because that was literally just the first pass, and just to be transparent, it's just a random forest. It's not even anything unique. I went back to the basics with that, and it was good enough.
While you were rebooting, Rami and I were talking about that. Is a lot of times going back to the basics is the right thing to do, because it gets you closer to where you need to be without over engineering things. So another question as we're wrapping up, and guys, we'll probably have like 5-10 more minutes, so if you do have questions, feel free to ask here. But is there an instruction set like framework available for using HVX and HMX on the HTTP of the QCS 6490?
Oh.
So they're asking about essentially running custom models on QCS.
Correct. Again, Genie isn't supported, but if you are running your own custom model and you want to run, there is a list of supported opcodes that are available that it could run. LLMs are tricky, but there are some resources available to get it up and running. And actually, in the plans, stay tuned. There is a plan to do an LLM on IoT chipsets, like kind of like this, a build along /dev release. And actually, I'll post. We got it up and running on Onyx runtime, so I'll post that repo here too.
Okay, cool. Yeah, thanks. Yeah, and one other thing I was thinking about that I did want to call out here is as we're talking about this, what Derrick and Rami have built is they're using one X Elite and one IoT device to interact with it, but this is also scalable. So of course, there's work that goes into any changes you want to do to software, but again, if you take your IoT kit and you have 1, 2, 3, for example, and they're all connected to the same X Elite, then you're actually able to essentially direct these requests, and you can really put different personas on each of these and really spread out the tool calling. So it doesn't all have to be on one device. Of course, it's more challenging to set up all those communication protocols, but once you get the framework and the basics down and you understand, okay, how does MCP work? How are we interacting? What are the commands? It's very, very flexible.
Yeah, and I think, and another thing to kind of tap on is, since we have the client built, like I said, we're doing use our client that we built and create whatever tools that you want, and just fire up the client, fire up the server for the on your IoT device, and watch how it interacts. So this is just the starting point. Nick mentioned like a framework, and I didn't even think about it in terms of that, because nobody really talks about the client, at least when, a month ago when we were trying to figure this out, nobody really talked about, everybody was talking about tool calling, how to do tools. Nobody talks about how to develop clients, because, that's Anthropic has that.
And we're here, to talk about this stuff. So as the repo drops, Derrick and Rami have put a lot of effort into this, and we've essentially scratched the surface. Trust me. I mean, like Derrick and I have spent, at this point, probably hours, and Rami too, talking about all the different things that have been done, how it works. So, as you get access to the repo, which, like I said, we'll post shortly, you can add us on Discord or submit pull requests or issues on GitHub so we see them, and we're monitoring those, and we're happy to talk about it. And even to the extent possible, we'll support you guys and maybe give you support calls and all that, when we have the ability, to make sure you really understand what's going on. And anytime you build something, like if you do use this, send it our way, shout it out on Discord, and we have ways to highlight these projects, and we want to share them with the community, because Edge is so new, and it's, if you ask me, and hopefully Derrick and Rami too, it's the future of, computing, because it's going to help us move beyond the limiting form factors, I said limiting, but of laptops and towers.
Yeah. And like I said, this goes, I want to keep emphasizing that this is significantly faster, typically, even on CPU.
Yeah. That's a part of anybody
I
who
think-
does software engineering they're used to it, the resource battle. So,
But I think we are in the correct format now.
yeah, it looks a little bit, I mean, we'll see when it's done.
Oh,
So as we start to wrap up here, there aren't any other questions coming in. So any closing thoughts about, kind of what we talked about today, next steps you want to see from people, or, anything you're going to be working on next?
yes. So the main thing, I think the main thing that, I'm going to keep on. I have some more ideas on the innovative, like the local side, whether it's with respect to tool calling and just stuff like that. I have some, so keep on hammering on this. We may be presenting this again at a big conference coming up.
Yeah.
But yeah, it's, if people want to see how to actually get the client implemented, we can, please, demand that, and we can set that up as well, because like I said, that is the meat of, kind of everything.
Yeah. And we want to do what, the developer community wants to see. So as, for everyone who's joined live and has been asking questions, we're happy to go into whatever direction you want, even to the point of potentially doing workshops. We travel pretty often, and we host hackathons and workshops and other types of events. And, we have content that we build up over time. So, if this is what you want to see, great. We're happy to bring it, wherever you are. And then we can do other stuff too. So anything that, drop it in the Discord in the appropriate channel. And there's, we're watching, there's others watching, the community managers are watching, and, we'll make sure we're bringing you the right content.
Yep.
Rami, any
Anything
closing
else, man?
thoughts?
No, I'm really excited, and there seems to be a lot of excitement on LLMs on IoT. So stay
Yes.
tuned. We'll release some content around that as well.
Yeah. So, okay. Well, I think this was really cool. Derrick and Rami, you guys did such a great job. I'm excited to play around with this when the GitHub repo drops, because I have not. And yeah, we'll see. As I said before, just to wrap up, as you guys play with this, please feel free to submit pull requests, issues, talk to us on GitHub, YouTube comments. I mean, we're watching all of it, and we'll make sure that if you get stuck, you're unblocked, and we'll make sure we keep pushing the boundaries of what's possible. Derrick and Rami are really good at that, so there will be more to come for sure.
Yeah.
Are you trying one more
Yep.
time? Oh no.
Oh yeah, no, it's working now.
hey.
I don't. Yeah.
And
Yeah.
actually,
in the final, after doing so, yeah, this is what I was trying to say. You can use, so whether you have resources, tools, you can actually ping this, and you can see what, like, I know for begin routine, I need to have, a JSON format, so you can actually fine tune your tools and make sure they're right before, like it needs to be in this.
yeah. And that was the
format.
socket issue that was blocking that, right? So now it's working.
Yeah. Yep. So that's a
Cool.
good problem to have. And then you can say run tool, and it'll tell you if it ran it or not.
Nice. That's
So,
awesome.
Yeah.
Cool. I'm glad we got to see this at the very end. Because it's tools like this that really enable you. It's like the auto docs when you're doing fast API, it's like it makes your life so much easier to have things like this. I do also want to mention as we wrap up, there's one other exciting thing, a couple exciting things coming up, but I can only talk about a couple. The first thing is in mid-September, so in a roughly 3 weeks, on the 13th and 14th of September, we're going to be in New York City hosting a hackathon. It's the finale of our Global Edge AI Hackathon. So if you're in the New York area and you want to travel, there's a submission page, which will hopefully be getting dropped in the chat here shortly. But you just have to tell us your idea. What do you want to build at the edge? We'll bring the hardware, and then, you'll have 24 hours in this hackathon to build and show us, what you're capable of building and hopefully innovating something that's really incredible that we can then share out, to the community. And all of this is collaborative. So you like hackathons, you like a challenge, you like potentially winning cool prizes, definitely come check that out. And we have another one coming up at the end of the month as well. And that's going to be at Princeton. So it's pretty close, back to back 2 weeks. So if either one of those are near you, please feel free to register for those, submit your proposal, and we'll get you on board. And with that, I think we're going to wrap this one up. So as always, thank you to everyone for joining. It was great. I know we always have some technical difficulties because that's just the nature of live streams, and it's part of the journey. But thank you so much for sticking with us. Thanks for the questions, and I'm really excited to see what you guys can build. Any final closing thoughts? You had pre-closing thoughts. These are the final closing thoughts, Derrick and Rami. Nope. Okay, great. Well, this is it for us. We're signing off. Thanks a ton for being here, and we'll see you for the next one. So we'll see you next time.
Have a good one.
Bye.